Hello students, let's try to understand the bonding in coordination compound. A bonding in coordination compound, that is also called the valence bond theory, student, right? So how can we understand what are the silent feature of the valence bond theory, student? The first point which we have to understand, student, is the central metal ion has number of empty orbitals for accommodating electron donated by the ligands. The number of empty orbital is equal to the coordination number of the metal ions for the particular complex. So that is, the number of empty orbital is what is the coordination number. So Cn is equal to what is, student? Number of empty orbital, empty orbitals. This is what is the first point, student. Now go for the second point. What the second point is all about, student? If you talk about the second point, friend, so let us see the second point. The atomic orbital sp(d) of the metal ion hybridized to form the orbitals with the definite directional properties. These hybrid orbitals now overlap with the ligand orbital to form the strong chemical bond. That is what. Second one, the d orbital involved in the hybridization may be either inner n-1d orbital or outer nd orbital. The complexes from these two ways are referred as low spin and high spin complexes. If n-1 d is used, student, that is called the low spin, student, low spin. And if it is nd orbital, student, that is called high spin, student, that is high spin. Each ligand contain lone pair electron, student. Each ligand contain lone pair electron. A covalent bond is formed by the overlap of vacant orbital, a vacant hybridized metal orbital, and a filled orbital of the ligand. The bond is also sometimes called the coordinate bond. If the complex contain unpaired electron, it is paramagnetic in nature, while if it does not contain unpaired electron, it is diamagnetic in nature. The number of unpaired electron in the complex point out the geometry of the complex as well as the hybridization of central metal ion and vice versa. In the practice, the number of unpaired electron in a complex is found to be the magnetic moment measurement as illustrated below. So mu s is equal to n plus 2 root of n plus 2, where is number of n paired. N is what, student? Number of n paired electron. Thus, knowledge of magnetic moment can be great help ascertaining the types of complex. Under the influence of a strong ligand, the electron can be forced to paired up the Hund's rule maximum multiplicity. So, against the Hund's rule maximum multiplicity, electron will be paired. What are the drawbacks, student? It describes bonding in coordination compound only qualitatively. It does not offer any explanation for the optical absorption spectra of the complex. It does not describe the detailed magnetic properties of the coordination compound. So, this is all about the postulates of the valence bond theory, student. Thank you so much for watching, friends.